Claim. The claim is that 3,3CD is impossible. In other words, if I actually have 4 polygons meeting at a vertex, and 2 of them are triangles, and 2 of them are something else, where C is either a square or a pentagon, and D is a I don't know yet, then I claim that they can't be oriented around that vertex in the order triangle, triangle, square or pentagon, other. Why not? Alright, this part I kind of didn't sketch out so well, but I think it goes something like this, man. If you had a triangle, and so feel free to like help me here, I guess. If you have a triangle, right? This is my sort of arbitrary triangle. And imagine that at this vertex, there was like another triangle, also like adjacent to it, okay? So this was like 3, 3. And therefore, like C and D were going to be over here, yeah? Okay, but if that's the case, well then...
You have to tessellate like all the time.
3, 3, no. What is the argument? The argument goes, okay, well this is also a 3, right? So there would also have to be a triangle here. Agree? So now I put a triangle here. Okay, but if there's a triangle here,
now there's 3 triangles.
now there's like another, this, right, if this is a triangle, and it has to be because this has to be a 3 because this is as well, then that adjacent thing must also be a triangle. And now I have like 3, 3, 3, and that can't happen. Right? Okay, that was like a little loose. Does anyone want to say that better? I think I said that okay.
No one wants to say it.
Okay. No one wants to say it better. Alright, good. Therefore, so our conclusion is that it must be in the form 3C, 3D. That's the only possibility. Okay?
Yeah.
And a further claim I now make, I'll do this right here, that C must be equal to D. This is also not obvious at all. But here is this argument. Okay, well, if C, so take a triangle, and what's going on, once we know it's in the form 3C, 3D, then that means there must be like another triangle here, right? And also like another triangle here, and also like another triangle here. And then this is like a 3, right? And this is a 3, and 3, and 3, and 3, and 3. But if this is a C-sided polygon there, and a D-sided polygon here, then this is a C, or then this is a C-sided polygon, right? And so this is like a C, and then this would have to be a D, and then this would have to be a D, and then this would have to be a C, and again, it's that same kind of lemma again, sort of ish, or same style logic. And so C has to be D. Alright, so once we conclude that C has to be 4 or 5, and that C has to be D, and they have to go in this orientation, then there's only 2 possibilities left, right? 3, 4, 3, 4, what's that? Cube octahedron. And 3, 5, 3, 5, which is the icosahedrodecahedron. No, we're not far away at all. Only 2 pages left.
Yep.
All right, good. Case, perfect. All right, here we go. Case 2-2. All right, case 2-2 is when n is 4, but now b is 4. Because we already knew there had to be a triangle. And so what does it look like? It looks like 3, 4, CD. Right, there is a triangle, and the next biggest shape is a square. Okay, well here it's not so hard actually, because if C is greater than or equal to 5, we got bad. Because now the sum of the angles at V sub I would be greater than or equal to, I have a 60, I have a 90, I have a 108, and the other one is at least 108. and that is already 366, which is greater than 360, contradiction. So C can't be greater than or equal to 5. So what is C? Have to be 4. So C just has to be 4. And therefore, if C is 4, then the vertices meeting there are 3, 4, 4D.
That's been so long.
Right? Also, D can't be that big. If D is greater than or equal to 6, then the sum of the angles at V sub I is greater than or equal to, I have a 60, I have 2 squares, and I have at least a 120, which is already 360, contradiction. Alright, so what can D be? So D has to be 4 or 5. Alright, erase all that stuff over there. If D has to be 4 or 5, well, first of all, if D is 4, then what happens? Then it's just 3, 4, 4, 4, and what that means is, Josephine and others are saying, then the order is irrelevant because it just is 3, 4, 4, 4, and what is that? That's the rhombocuboctahedron. Woo! All right, and if D is 5, then what? If D is 5, then that means that the set of polygons meeting at a vertex is 3, 4, 4, 5, right? Okay, and now there are 2 possibilities. If there's a triangle and 2 squares and a pentagon meeting at a vertex, there appear to be 2 different possibilities. They could meet in the 3, 4, 5, 4 arrangement. What's that? Rhombi-costododecahedron. Hello. What's the other possibility? They could meet in a 3, 4, 4, 5 arrangement. Well, that turns out to be impossible by the following argument. Try to start doing it, man. If you have a triangle and you have a square here, and then that has to be, this is like 3, right? So this is a 4, so that means there also has to be a square here, and this is 4, and this is 5. But then that means that at this other vertex, it has to also look like that. So we also have to have a square here, making this a 3 and a 4 and a 4 and a 5. But now, that's impossible because
You have 2 5s at the top.
zoom! Yeah, this has to be a 5 and a 5, and now this vertex is not the same.
2 more.
Good. So that's impossible. All right, case 2 has now finished, and we are on to case 3.
Oh my.
Yeah, Ray. I'm a professional. Case 3. Case 3 is n equals 5. Okay, this is the case in which there are 5 polygons meeting at a vertex. All right, and they are V1, V2, V3, V4, and V5. And so let each vertex be, as before, a member of the set A, B, C, D, E, where we list them in like increasing order. Okay. And now, look, because there are so many vertices, I claim that D, the 4th biggest, can't be bigger than or equal to 4. Because if it is, then the sum of the angles at V sub I is greater than or equal to, well, if D is 4, then all the ones less than it are
3. Or
have to be
at least 3.
have to be at least 3. So that means they're each at least 60, and then D is at least, then D is 90 and E is 90 at least. And this is already 360. Impossible. That was like a little fast. All right, so what does that mean? That means that D has to be less than 4. Stop talking. But if D is less than 4, then what does that tell me? Then A and B and C and D all have to be 4. 3. All right, and then again, if E is greater than or equal to 6, then it doesn't work. Because now the sum of the angles at V sub I is going to be greater than or equal to, well, I have 4 triangles already, and then the 5th one is like a hexagon, that's 360, impossible. All right, so what can E be? 3, 4, or 5. All right, and so here's the only things left. They could be all 3s, but now do you see that like if they're all 3s, then like the order is irrelevant, right?
Yeah,
so this just is 3, 3, 3, 3, 3. What's that? The icosahedron. And the other option is that it's 3, 3, 3, 3. What did I say?
Nothing.
Good. What about if it's 3, 3, 3, 3, 4? Well, again, then that's just the one with, this is just this. What's this? Snub cube. And on the other hand, if the 5 polygons are 3, 3, 3, 3, 3, 5, then again, the arrangement, there's only one possible arrangement, which is this one. What's that? That's the snub dodecahedron, and we've run out of possible cases. Those are all the Archimedean solids. Good. See you guys tomorrow for a test on graph theory. Goodbye.
We'll still have the polyhedra in the